again, we've seen questions like this before with implicit differentiation. We have x squared plus y squared equals 16. So if we differentiated with respect to x on both sides, the part with the y would have a chain rule where you get your dy dx, and then you can solve for dy dx to be negative 2x over 2y, which reduces just to negative x over y. So these are called separable because in order to solve them, we need to have an equation with y on one side and x on the other. So let's say you had a differential equation with x squared and y. What we're going to do is we're going to get the y on one side and the x on the other, and we're also going to play around with the dy dx. And again, this is where Leibniz notation works out really nice for us, because if we integrate both sides, we can integrate one side in terms of y and the other side in terms of x. And again here, it seems like we're cheating a little bit because dy dx means the derivative, and yet we're just like treating it like a fraction and breaking things up. But it works out nicely, so we do it. So we'll have y squared over 2 on the left-hand side plus c1, and x cubed over 3 plus c2 on the other side. And you could leave it like this. Of course, you could put the c1 and the c2 together just to be c, because they're both constants, so we can say, well, together there's some other constant. And if you left it like this, it would be considered an implicit equation because you don't have y by itself. We could, if we wanted to, rearrange this and get y by itself, and then that would be an explicit equation. So we solve this. This is new. We solve this by separating the y and the dy on one side, the x and the dx on the other side, so that when we integrate both sides, one side we're integrating in terms of y, the other side we're integrating in terms of x. So let's look at a couple more, and then I'll get you to try some on your own. So normally, if you want to find a particular solution, you just have to integrate. The problem with integrating is we have x's and y's. But if we first separate this by having our y's on one side and our x's on the other, so can you see that I multiplied both sides by dx? And when I divided by the square root of y, that would put that square root of the y on the bottom. Here I just rewrote it as y to the negative 1/2. And again, just like all of our other integration, we are working at rearranging things so that they look like something we can easily do the integral of. I can easily integrate y to the negative a half. I can easily integrate x squared. And because the y side is in terms of y, we just integrate like normal. And because the x side is in terms of x, we can integrate like normal. Can put our c's together, and we have an implicit equation that the square root of y is x cubed over 6 plus c. If I wanted to just get y by itself, I'd have to square both sides. Yes. Oh, I am muted. Thank you. So, and that was the silent version of this question. It's just Brady. Brady can learn in silence. Hey. Hopefully, oh, it's probably muted for the one before this then too. All right, we'll do one with sound. So again, just like the previous questions, move your y's to one side, separate your y's, separate your x's. Integrate both sides. And now because you're adding and subtracting, you would integrate each part separately. So the y by itself would be y squared over 2. The minus 1 would be minus y, and then you have a plus c1 on the left. Same thing happens on the right side, an easy integral, plus c2. And multiply everything by 2, put your c's together. And you get y squared minus 2y equals x squared plus 2x plus c. That is our implicit equation. Do you want to, for fun, get the explicit one? What would you have to do? You'd have to complete the square, right? You could factor out a y, but then you still have two y's. It's kind of problematic. What I'm going to do is I am going to add 1 to this side. If I add 1 to this side, I need to add 1 to this side. Can you see that this nicely factors to y minus 1 squared? Technically, this nicely factors to x plus 1 squared. And then we still have the plus c on this side, right? So if I wanted to get y by itself, I could square root both sides and get y minus 1 equals plus or minus the square root of x plus 1 squared plus c. And then to get y by itself, that would be an explicit equation. So again, that completing the square that we thought we could get rid of, comes back again. Okay, so 3 more for you to try. Here's the answer to the first one, so you can check. If you left it like this, you left it as the implicit one, right? This is most likely. So here we move the y over, integrate both sides, get the natural log of the absolute value of y, And so right here, we're probably feeling pretty good about getting to that. Okay? Now, if you wanted to get the explicit equation and get y by itself, how do you solve for y inside of a natural logarithm? Change it to exponential form. The base is e. This whole thing would be the exponent, and that would get you y by itself. Okay? Technically, absolute value of y, but because this is always positive anyways, you don't need the absolute value anymore. Now, you could leave it, definitely, this is perfect. Put a little red box around this. That's your explicit equation. Leave it like that, you're perfectly fine. Okay? If you want to play around with your exponent rules, right? Adding exponents is the same as multiplying, and e to the c is just another number, so you could change it. Probably shouldn't change it to c. Technically, I should make this a d, because I made e to the c equal a new constant. Or I could have made this c c3 and this c4. I think the red box is, just leave it as a red box, it's fine. Okay? But if you had a multiple choice question, I don't know, do they do multiple choice today? Yeah. Oh, yeah. Oh, and they gave you the answer as the blue box, you'd be like, how do I do that? The answer is, I don't, I guess. Mr. Jerry, you figured out my main strategy. The main strategy that I use is, I don't know, I guess.
Oh, that's me in chemistry.
That's you in chemistry?
It's close enough.
That's a chemistry strategy.
It's close enough. See, but like, if it's close, then it's definitely not the right answer. You know?
It's probably there to tempt you, right?
Yeah.
All right, how did this one go? Ooh, we have a y. How do we get the x and y separated? We're going to have to use factoring. And then you can separate your x's and your y's. So now we have a little bit more work to do just to get our x's and y's separate. And then, of course, integrate both sides. And this would be fine. And this would be fine as well. So I put a red box. Well, we move the 2 over. That would be fine, or that would be fine. Put a red box around that one too. If you wanted to play around with your exponent laws, that e to the c could come out in front. Maybe I'll make this c3. And then change e to the c3 to c. Too many c's. Constant 1, constant 2, constant 3. Right? Again, on multiple choice, they're not going to be worried about your messy notation. You could just call them all c's and just forget about what? C1, C2, C3. On a long answer, they're going to be looking at notation. So then you have to be more careful. Right. I mean, if this is multiple choice, you don't know where their C went. They don't know what letters you used along the way. If we're doing this properly, either leaving it like this with the C would be fine, or if you manipulate it further, like that with a C would be fine. Right?
Okay, now it's a bit more better.
No, I think it's ahead.
Alright.
I calculated my work directions for your units. And by that I estimated
So find the solution to this differential equation, xy all squared, with the initial condition, y1 equals 1. So you could square the right side to get x squared, y squared, and then you could separate. So again, we're starting to recognize that if you get a derivative, and the derivative has both x's and y's, and you're asked to solve it, you're going to have to separate your x's on one side, y's on the other, and then integrate from there. Now this one gives us an initial condition, and so when we get our c value, we're going to be able to solve for it. So we've got our equation here, but you know that when y is 1, x is 1, you can plug in both of those values. No need to rearrange and solve too much to get y by itself. At this point, once I have c, now I can go back and plug in c. Now from here, if I wanted to, I can get y by itself. If you have a fraction, equal a fraction. Did you know the following? Did you know that 2 7s is equal to 4 14ths? And if I flip both sides, is it still true if I flip both sides? Yes, right? So if you do have a fraction equals a fraction, you could just flip both sides. That works out nicely. Then I can move my negative over to get y by itself. All right, try this one on your own.
Next week. Yeah, it's like the first thing.
Got 2 more questions. This is what we want to finish up. Try the last 2 on your own. I'll put them up in 3 minutes. I'll put up all the answers. I skipped this one? No, we did this one. Oh, my notes is missing one?
Yeah.
Okay, leave that one for on your own. Do the last one. Then, hey, we're done quicker.
What?
Unless I have it. Do I have it next? No, I don't. It's all good. Just missed one.
Probably just thought it wasn't a question. Do the last one. Okay.
Yeah, do the last one. Leave the second last one fun for yourself on your own. It's not hard. Oh, it's too easy. That's why I skipped it. All right, I'll put up the answer and check how you did. Another natural log. Plug in values. C is equal to -1. Here's a possibility, or you could write it like that. Do you like that e to the x?
Isn't that the special?
It seems special. E to the x minus 1. Technically, this whole thing is in the exponent, right? Maybe put it in brackets so you don't.
So how did it get in the bracket?
Because you take the natural log and change to exponential.
Yes. Okay.
That is it for today.